we just need to move on with our next presenter, Dr. Saeed. Thank you so much, Dr. Fatma, for this insightful presentation. I think people are very interested about your work, but we can continue the questions in the chat. Thank you so much.
Yeah, no, Dr. Madini, if I just may, so sorry for Dr. Fatma. I was thinking there was more composite. I was not thinking of a single fiber, so that I was questioning on the tensile strength. So my apology for that.
No, never mind.
Thank you.
You're welcome. Thank you.
Right, Dr. Saeed, please.
Yes, so hello everyone. Just a brief introduction about myself. I was working on my PhD on date palm fibers and mainly on understanding the geometry of the fiber and then implementing it in different types of composite development. So to start with, can you manage to see my screen?
No, we cannot see. I cannot see your screen.
All right. So currently.
So now it's showing.
Yep.
Mm-hmm.
All right. So basically,
if you could put on PowerPoint mode, please. If you could put on PowerPoint mode.
Like full screen.
Presentation mode, yeah, full screen.
You can click F5.
Yes, done it. Yep.
Yeah.
Is that good? So basically, one of the areas that was interesting in my research is to understand and evaluate the effect of processing parameters on both the physical and mechanical properties of developing a composite. So to give a brief introduction on why this topic is interesting is due to the new legislations by the European Union and globally moving towards sustainable manufacturing and minimizing agricultural biomass waste. The date palm fiber accounts to roughly around 2.6 to 2.8 million tons annually deposited into landfills, which is considered a huge amount of agricultural waste in the MENA region, and highlights the importance of its utilization in developing various types of composites that can be implemented in various industrial applications. However, to date, there are very minimal amounts of research that indicates its optimization and upscaling into the feasibility on developing an end product that can be commercialized. And to start with, I have tried to develop a few benchmarks on what type of fibers can be used in which areas and the amount of date palm fibers that are extracted from each part of the date palm tree to solidify each country, the amount of waste that they have and the feasibility of it to develop on an upscale. So I do believe Dr. Libna and Dr. Mohammed Medani have done first a review on the amount of waste and the composites developed through date palm fiber, and then I have expanded on top of that. This is a small table that discusses each country, how much does it have date palm tree waste in tons, and from each part of the date palm tree that has been extracted to give a rough idea if there's the amount of waste available in that country in order to upscale if the experimental or the pilot scales have a good results or good outcomes. Here in this slide, we can see that the date palm fiber already possesses a good characteristics in both physical and mechanical properties, which entitles it to compete with other different natural fibers that are available around the world. So if we consider talking about the date palm fiber, we will be focusing mainly in the MENA region, where it is the most abundant. However, hemp and sisal and bamboo slacks in those areas. So when we developed a comparison between date palm fiber and hemp and corn sisal or bamboo, we can see that they almost have the same characteristics. However, there are few points or few areas that date palm fiber are more superior than the rest of the natural fiber, which is the first is the density and the cost of the material. And in terms of physical strength and the mechanical strength, the date palm fiber is slightly lower than the rest of the fibers. However, the advantages of it is the abundancy in the region that it is collected or utilized, and its density for developing low cost material and a low weight or lightweight materials. So based on the research that I have currently done, there are almost 32 articles or publications specifying the optimization factors on different treatments on date palm fiber, different surface treatments. However, to date, there's no specific optimization. Mainly, everyone uses sodium hydroxide on different concentrations and different durations and different temperatures. And they all are based on other people's research or other people's publications. However, today there's still yet a lack in optimizing the date palm fiber surface treatments. As well, there is a lack in understanding the effect of date palm fiber geometry in developing sustainable composites. And to date, there is zero publications on the effect of processing parameters on date palm fiber composites. So they have minimal investigations on different natural fibers and the processing parameters. However, on date palm fiber, no one has investigated the effect of processing parameters. When we want to mention or talk about processing parameters, we have three different factors that we have to look into. The materials utilized, the type of materials, we know that the date palm fiber is the filler or the reinforcement that will be used. And then we have the composite or the binder or the matrix system. So whether it is a cementitious composite that we're after, or we have a polymeric matrix that we want to develop, we have the thermostats and the thermoplastics. So the material utilized is the first thing that we need to investigate, or the processing parameters are crucial. Then we have the processing techniques, whether you want to develop it using an injection molding or extrusion system or compression molding, or just a hand layup technique. Then we need to investigate the processing techniques that we're going to develop the composite. And finally, we have the processing parameters that we need to investigate, which includes, let's say, the temperature, the pressure, the processing duration, that might vary in minutes, in degrees Celsius, and in tons for pressure. So as a benchmark or as a start, since most of the composites are being developed through compression moldings to develop either cladding or decking panels, I have investigated the effect of processing parameters on developing date palm fibers with polyester resin. The main reason of me using polyester resin because I have investigated through different thermoplastic composites. I wanted to minimize the amount of machinery or equipment that I need to use in order to develop a composite. So using a thermostat enhances me to use a hand layup technique in the beginning, and then hot press the material in order to develop the final product. Whether if I'm going to use a thermoplastic, I would need to compound, grind, sieve, and then compression molding technique would be involved. So the chain is longer, more energy is required, and it will be less sustainable to develop the end product. So the experimental plan that I was investigating is the compression molding for 3 different durations, which is 3, 6, and 9 minutes, and 3 different pressures applied, which is 10, 15, and 20 tons at 2 different temperature degrees, which is 90 and 110. Unfortunately, in the parameters that I have used is based on a collection of different researchers that have done the same methodologies on different natural fibers. And I have taken the region of the minimal and the maximum and tried to allow a bit of increment increase to show if there is any difference in developing the composite or any effects on the physical and the mechanical properties. So after developing the composites, in order to evaluate the processing parameters effect, 2 types of testings, both mechanical and physical, were done. For the mechanical, the tensile strength, flexural strength, and the impact strength were evaluated. And for the physical testing, the thickness, swelling, and water absorption were evaluated. Basically, before utilizing the fiber and developing the composite, I have done the sieve analysis and I have done different sievings. The first image shows A, B, C, D, E, and F. We start with F, which is less than 125 micrometer. E is between 125 to 250, D is between 250 to 500, C is between 500 to 1,000, B is above 1,000, and A is the unsieved. So A has a combination of B to F altogether combined. The reason of me understanding or analyzing the sieve analysis is in order to investigate the amount of each sieve within the unsieved. This is one. Two, in order to understand that each sieve analysis have a different density, and how will the density affect when combining or developing a composite based on a volume ratio or based on a weight ratio. Since the density of date point fiber is low and the density of the thermoplastic or the polymeric matrix system is high, definitely the ratios will play a crucial role. So I have done the hand layup technique, which shows on the lower left image. And then after the hot press, it shows how the panels were developed, which were roughly around 30 centimeters by 30 centimeters, which were then cut through a bandsaw into the standard of 10 centimeters in length and 1 centimeter in width, and tested through the various testing procedures that has been explained. So the results, I'm going to start with the physical results. It shows that the net polyester resin absorbed a minimal amount of water, which is around 0.68%, which might be due to the voids and the non-consistent mixing technique and the voids developed while processing the composite. And the rest, it shows that there is an increase, and there is a various increase depending on each variable of the processing parameters that has been utilized, which highlights that developing composites through different processing parameters do have a crucial effect on the physical properties. The highest result was absorbed for 90 degrees at 15 tons for 9 minutes. So that might be a lead of a damage through the polyester resin while processing, or the burning of damaging the fiber after the processing, while processing. Figure 2 shows the water absorption. Also, the various, as the time increases, the water absorption of the composite also increases. However, there are some results that show that there is a certain parameter that shows a minimal increase, or a certain parameter or a combination of parameters have the best ratio. So all the 9 minutes duration processing techniques showed an increase on the water absorption. However, if we take the 9 minutes on the 10 tons along with 110 degrees, it shows a very low water absorption and almost lower than the rest. So the analysis or the microstructure of the composite developed should be analyzed very carefully in order to understand the phenomena behind this. Looking at the flexural strength, the processing parameters affected, or the addition of date point fiber affected the development of the composite negatively by reducing its strength, which might be due to the hydrophilic nature of the composite, along with no chemical treatment was used for the fibers, no additives was used. So there is a lack in the interfacial bonding between the fiber and the polymeric matrix, which caused the decrease in the flexural strength. However, the entitlement on the different processing parameters on the flexural strength are obvious in this diagram, and each combination of processing conditions have a different effect and a different role on the mechanical properties of the composite developed. This is also how the modulus get affected by the flexural, by the processing parameters. And the results are a bit various depending on each condition. And the only justification behind this will be the microstructure analysis, which unfortunately have not been yet analyzed due to the closure of the country due to COVID-19. However, we will be waiting in order to carry out all microstructure analysis that can justify these results. So also looking at the tensile strength, although the flexural strength decreased on all aspects of using the filler, the tensile strength increased for the 3 minutes and for the 9 minutes for 2 different conditions. If we look at the diagrams, higher temperature showed a better enhancement on the strength of the composites. However, the medium, like for example, for the 9 minutes, the 15 tons showed the lowest drop in strength. So each parameter played a different role. And finally, the impact strength also varied according to the different processing parameters utilized. So if we wanna conclude on the outcomes of the first initial investigations on the effect of processing parameters on development of composite, this was only one scenario taken into consideration of utilizing a thermoset. However, if we're gonna look into the development of dead pan fiber reinforced thermoplastics, we need to take into consideration the melt mixing technique, the grinding technique, and also the compression molding. So the combination of, as the variables and the processing conditions or processing techniques increase in line, there will be so many variables that should be taken into consideration and analyzed and optimized in order to achieve the optimal composite development. And even if we want to look in another perspective, developing dead pan fiber reinforced plasters or dead pan fiber reinforced cementitious composite, the cement to binder ratio along with the water to cement ratio is a crucial factor that yet no one has highlighted this aspect, since dead pan fiber is a hydrophilic material and it will absorb most of the water while being processed. So unfortunately, till date, dead pan fiber reinforced composite have not been investigated in the terms of processing parameters and in terms of understanding the fiber geometry's effect on developing the composites. So I believe that's it briefly, and I would be more than happy to get your question.